Okay, let's continue on with our next video. All right, it says solve symbolically and express your solution using interval notation. And it tells you to check your work. Okay, that's going to be a little bit challenging and we really haven't talked about that. All right, so I can have plenty of room here, I'm gonna write this over here. If I have 3x minus 3 is greater than 2x plus 1. Remember when I'm solving, you remember you have to flip the inequality if you multiply or divide by a negative number. That's usually in the last step, so you don't even have to think about it until you get to that last step. Okay, so I like to have my variables on the left, so I'm going to subtract 2x from both sides. When I do that, that gives me x minus 3 is greater than 1. From here to get the x by itself, I add 3 to both sides, and that gives me that x is greater than 4. Okay, now in terms of checking it, you would have to put some number in there greater than 4 and see if it's true. But let's go ahead and write our solution set. If x is greater than 4, then in interval notation, this is from 4 to infinity. So I think we're okay with that. Now, if I wanted to do a quick check on this, I would let x be something greater than 4. So let x equal 5. So I would want to know if 3 times 5 minus 3 is greater than 2 times 5 plus 1. Well, 15 minus 3, I want to know if that's greater than 10 plus 1. 12 is greater than 11, so that checks. Okay, my next one here is kind of the same thing. And again, this one needs a little bit more room. All right, so I think what I'm going to do here first is I will distribute. So that gives me 3 minus 2x is greater than or equal to 5x minus 65. Had to check my arithmetic there real quickly. Okay, I still like having the variables on the left, so I'm going to subtract 5x from both sides. That gives me 3 minus 7x is greater than or equal to negative 65. I've got to switch colors. Okay, I want this by itself, so I'll subtract 3 from both sides. And that gives me negative 7x is greater than or equal to negative 68. Here I'm dividing by a negative 7. So that means my greater than or equal becomes less than or equal. And I have x is less than or equal, negative divided by a negative is a positive 68 over 7. So less than or equal means I go from negative infinity to 68 over 7. It includes that, so it's a bracket. Okay, you want to get rid of the fractions, so you look at the least common denominator. The least common denominator is 6. So I'm going to multiply this by 6 and this by 6. So 6 times 1/2 gives me 3 times x minus 5 is greater than or equal to negative 2 times x plus 1. Okay, in this step, I'm going to distribute. So that gives me 3x minus 15 is greater than or equal to negative 2x minus 2. I'll add 2x to both sides. And that gives me 5x minus 15 is greater than or equal to negative 2. Continuing to get to the x by itself, I add 15 to both sides. That gives me 5x is greater than or equal to 13. When I divide by 5, here I'm dividing by a positive number, so this remains greater than or equal to, and I get x is greater than or equal to 13 over 5. And that takes me in my interval notation. Greater than or equal to means that my lower number is 13 over 5, and then it goes on to infinity. Since it includes the 13 over 5, it's a bracket. Okay, when I'm solving an inequality like this with the betweenness, let's see what it says here. Solve it, express using interval notation. Okay, so I know how I need to do my answer. It tells me in the question. Okay, so what I have to remember here is now I have 3 pieces to the inequality. So whatever I do to one piece, I want to do to all of them. So I'm going to, in order to get rid of this denominator, I'm going to multiply the entire equation by 4. And I'll go ahead and spell this step out. So this becomes 4 times negative 3 is less than 4 times x minus 3 divided by 4 is less than 4 times 2. Okay. So this gives me negative 12 is less than or equal to x minus 3, which is less than 8. Okay, so now I'm just going to add 3. Since I'm doing it here, I have to do it here, and I have to do it here. So that gives me negative 9. Whoops, and there's no less than or equal there. I'm sorry. Is less than x is less than 11. So in interval notation, this goes from negative 9 to 11. Okay, now I'm going to show you the difference here of why. Well, no, we'll just work it out. Okay, got fractions again. So what I want to do is multiply by the least common denominator, which is 6. That is the smallest number that is divisible by 2 and divisible by 3 and divisible by 6. Now, if you got any common denominator, that's fine. You can do that. It's just you're going to have to simplify at the end. Okay, so I'm going to multiply this whole equation by 6. So once again, I'm going to close it in intermediate steps. So this is 6 times negative 1/2 is less than 6 times negative 1/3 x minus 1 is less than or equal to 6 times 1/6. So this gives me negative 3 is less than, I have to distribute here now, 6 times negative 1/3 is negative 2. 6 times negative, I'm sorry, and that's negative 2x. 6 times negative 1 is negative 6. And 6 times 1/6 is 1. Now it's pretty standard, so I'm going to add 6 in all 3 places. So that gives me 3 is less than negative 2x is less than 7. Okay. Now I'm going to divide by negative 2. So I have to flip the inequalities. So this becomes greater than, this becomes greater than. So I have negative 3/2 is greater than x is greater than negative 7/2. I keep messing this up. That's less than or equal, so that's going to be greater than or equal. Now, we normally go from smallest to largest, so I can rewrite this, just take the whole thing and turn it around as -7/2 is less than or equal to x is less than -3/2. And then in interval notation, it goes from -7/2, that's going to be the smallest, -3/2 is the largest, and I close my parentheses. Okay, there's not enough room on here, so I'm going to do these. I have room for this one. I'll do these on a separate piece of paper. Okay, so if I have an absolute value equation, if the absolute value is equal to 10, then that means that what's inside here, the 4x minus 2 can be equal to 10, or 4x minus 2 is equal to -10. Because if this is equal to -10, when you take the absolute value of -10, it's 10. If this is equal to 10, the absolute value of 10 is 10. Okay, so these are pretty simple then too. So I'm going to add 2 to both sides. That gives me 4x is equal to 12. When I divide by 4, I get that x is equal to 3. I'm going to do the same steps here. Add 2 to both sides. That gives me 4x is equal to -8. Divide by 4, and I get that x is equal to -2. And those are my two solutions. Okay, so on this next one, if I have 3 minus 5x is equal, the absolute value of that is equal to 1/4, then what that means is that 3 minus 5x is equal to 1/4, or 3 minus 5x is equal to -1/4. Okay, so you're probably going to want to, at this point, multiply this whole thing by 4 to get rid of the fraction, which gives me 12 minus 20x is equal to 1. Okay, so from here, I'll subtract 12 from both sides. And what that gives me is -20x is equal to -11. Divide both sides by -20. And I get that x is equal to negative divided by negative gives me a positive 11/20. Here I'll do the same thing. I'm going to multiply by 4. Notice my steps are identical. My answers are just different. Okay, so this gives me 12 minus 20x is equal to -1. Subtract 12 from both sides, and I get -20x is equal to -13. When I divide by -20, I get that x is equal to a positive 13/20. Okay, so let's see what I've got here. So this one, actually, I think I've got room for this one. So we'll see what we can do. So I know that I can split this up, and this becomes negative x minus 2 is equal to x plus 3. Negative x minus 2 is equal to the opposite of x plus 3. All right, so I will subtract x from both sides. That gives me negative 2 is equal, negative 2x minus 2 is equal to 3. Add 2 to both sides. I get that negative 2x is equal to 5. When I divide by negative 2, I get that x is equal to negative 5 halves. Okay. On this one, if I distribute the negative one, I get negative x minus 2 is equal to negative x minus 3. So again, I'm just taking this negative 1 and distributing it. All right, then I'll add x to both sides. And that gives me negative 2 is equal to negative 3. This is never true. So there is no solution to this portion. So this is your only solution. Okay, let's see what we've got here. All right, so I'll probably be able to do 2 on this page. Let's do these 2 on this page and those 2 on another page. All right, so if I have a less than or a less than or equal, that means that the distance from this is 11 in either direction. So this can either be negative 11 is less than or equal to 4x minus 7 is less than or equal to 11. All right, so let's add 7 to both sides. Actually, all 3 sides, right? So that gives me negative 4 is less than or equal to 4x is less than or equal to 18. I divide each of these by 4. I'm dividing by a positive number, so I don't have to mess with the inequalities. And this gives me negative 1 is less than or equal to x is less than or equal, and 18 over 4 reduces to 9 over 2. So in my interval notation, it's going to go from negative 1 to 9 halves. Okay, this is exactly the same. If this is less than 4/5, then it can be 4/5 this direction or 4/5 this direction, which means that negative 4/5 is less than or equal to 3 minus 2x is less than or equal to positive 4/5. Now, again, I'm kind of thinking that you guys want to get rid of the denominator, so I'm going to multiply everything times 5. 5 times negative 4/5 is negative 4. 5 times 3 is 15. 5 times negative 2x is negative 10x. 5 times 4/5 is 5. Okay, got to get this in the middle, this by itself. So let's subtract 15 from all 3 pieces. So that gives me negative 19 is less than or equal to 10x is less than or equal to negative 11. Oops, and I forgot my negative sign here. Okay, so I'm dividing by a negative number. It's an inequality, so I have to flip. So that gives me 19 tenths is greater than or equal to x is greater than or equal to 11 over 10. Or I can write it as flip the whole thing around because notice here, everything points to the left. So this is 11 tenths is less than or equal to x is less than or equal to 19 tenths. And that gives us in our interval notation 11 tenths, 19 tenths. And notice when you flip the inequality symbols, this takes care of itself because your result here, 11 tenths, is less than 19 tenths. And you know everything else has to be in between. Okay, if I have x plus 7 is greater than 4, I know I have to split this up into x plus 7 is greater than 4 or x plus 7 is less than negative 4. So this is pretty simple. So I'm going to add 7 to both sides. This tells me that x is greater than 11, except that that's minus. Oh, and I'm right at the end of the video. I'm not doing this one over again. So subtract 7, so x is greater than negative 3. Here I subtract 7, so x is less than negative 11. Okay, so let's see what I've got here. So if x is less than negative 11, that means so this one means I go from negative infinity to negative 11. And then I'm going to combine that with negative 3 to infinity. And again, you see that that makes sense because I go from negative infinity up to 11, jump over and go to negative 3. So if I were to do this on a number line, you would see that if I had negative 11 and negative 3, greater than negative 3 is here, less than negative 11 is here. So that's why you write it in this order, so you read it from left to right. Okay, and then my last one on this video, if this is greater than or equal to 7/3, then I know I have to turn this into two inequalities. Negative 3x minus 1 is greater than or equal to 7/3, or negative 3x minus 1 is less than or equal to negative 7/3. Okay, let's get rid of the fraction. So that means I'm going to multiply this whole thing by 3 and this whole thing by 3. So this gives me negative 9x minus 3 is greater than or equal to 7, or negative 9x minus 3 is less than or equal to negative 7. Okay, that seems a little bit more reasonable. So let's add 3 to both sides. That gives me negative 9x is greater than or equal to 10. Divide by negative 9, which means I have to flip. So this is less than or equal to. So I have x is less than or equal to negative 10 over 9. I'll do the same thing here. Add 3 to both sides. That gives me negative 9x is less than or equal to negative 4. When I divide both sides by negative 9, I have to flip. So less than or equal becomes greater than or equal x and 4 over 9. Okay, so this is the interval that goes from negative infinity to negative 10 over 9 with a bracket. And I'm going to combine that with the interval that goes from 4 over 9 to infinity.